Okay, let's talk about graphing the discrete probability distribution. So, in the graph of a discrete probability distribution, the horizontal axis represents the values of the discrete random variable. And the vertical axis represents the probabilities of the random variable. So this is our random variable x, and this is our probabilities p of x. So if we want to, let's go back and graph the shoe size probability distribution. Okay, so this is going to be a little hard to see probably. Let's see if I can make it where we can see it. So if we go back to our data, the probability of a shoe size of 4 was 0. So, whoa, that's a little bit too big. Sorry, let me get something a little bit more reasonable. So there's the probability of 4. The probability of a shoe size of 5 was 0.04. And the way our graph is marked, each little small grid line is 0.02. So for 0.04, it's right here. And then we draw a line connecting it to the horizontal axis. Okay, let's try a shoe size of 6 was 0.12. So that's right here. Oops. Except I put it at 7. Should have put it at 6. So 0.12. Shoe size of 7 was 0.08. So you guys should probably pause the video and graph these yourself if you can, and then restart and see if you got it right. So I'm just filling in the rest of them here. And 13 through 17 are all 0.08. So that's what our probability table looks like. Now really, we should have the horizontal axis labeled below the lines. It's just hard to find a decent graph template to add to the notes. So I'm just going to go ahead and put those values down there. So that's how we graph a discrete random variable and its probability distribution. Now let's talk about how we compute the mean and the standard deviation of these things. So the mean of a discrete random variable is given by this formula. We call it mu with a subscript of a capital X to tell us that it's the mean of a probability distribution of a discrete random variable. And what this formula says is that we multiply each value of the discrete random variable by its probability, and then we add all of those products up. So that's how we would do it by hand. Fortunately for you guys, we are now living in the age of technology, and so we will use our calculator to do this. So, to use the calculator, we use one-var stats, just like we did when finding the mean in chapter 3. But this time we put the values of the discrete random variable in list 1, and we put the probabilities in list 2. Then we make sure that we have L1 where it says list, and we make sure it has L2 where it says freak list, which is short for frequency list. And remember, the calculator will tell us that the mean is X bar, but we're going to use the symbol mu sub X when we do this. So it's important to know that the calculator notation is different from the mathematical notation we use. So let's find the mean using the calculator. So I am going to get my calculator, and I am going to pause after I enter while I enter the numbers, but just so you remember how to get there, you hit stat, and we want to edit, so we hit enter, and now we have our lists. Remember, if you need to clear something, you highlight the list name, hit clear, and hit enter, and then that whole list is cleared out and you can start entering data. So I'm going to pause while I do that so you don't have to watch it. Okay, I have all of my shoe sizes entered in list 1, and I have all the probabilities except the last one entered in list 2. What I wanted to show you was that if you had fractions instead of decimals for your probabilities, you could enter them right here in the list. So for shoe size 17, we had 2 divided by 25 for the probability. So we can just type that as a fraction. And when we hit enter, the calculator turns it to a decimal for us. Okay, now that we have that, we're going to hit second and quit to go back to our home screen. And we want one-var stats. So we go stat, over to calc, and we pick the first option. Now you see it says it already has L1 for the list. If it doesn't, so if for some reason you had something else or it was blank, remember you hit second and the 1 key to get L1. Then we need to go down to frequency list and hit second and L2 to put the frequency list as L2. Then we scroll down to calculate and hit enter. And you can see that our mean, our X bar, is 11.04. So remember, the calculator calls it X bar, but we are going to call it mu sub X, and that should be a capital X, and that's 11.04. And we got there by hitting the stat key, and then we went to the calc menu, and we went to one var stats. And for list, we put L1, and for freak list, we put L2. And L1 had our shoe sizes in this case. Remember, values of the random variable. And the frequency list had the probabilities. So how do we interpret that? Well, the mean of a discrete random variable can be thought of as the mean outcome. And the key here is it's the mean outcome if we repeated the experiment many times. So if we just do it once, we might not get anywhere close to a mean shoe size of 11.04. But if we, took lots and lots and lots of classes and repeated, this experiment many, many, many times, we would get approximately 11.04 for the mean shoe size. So that means we would expect the mean class shoe size of a stats class to be 11.04. Now, context can matter, right? In this country, we only do half-size shoe sizes, and in the experiment we did, we only did whole shoe sizes, so we would probably say we expect it to be an 11, not an 11.04. Okay, the next type of mean we're going to talk about is a weighted mean, but we'll do that in the next video.